Hi students, welcome to my channel. Today I am discussing about protein denaturation. First we should know that what is the active protein or native protein. So native protein means the protein formed in biological system with a unique three-dimensional structure. Three-dimensional structure and having biological activity. Already we studied the protein structure. One is primary, secondary, tertiary and quaternary. In that, tertiary structure is further folded of a secondary structure that is exists in three-dimensional structure and which is stabilized by some intermolecular forces. One, hydrogen bonding and van der Waals forces and electrostatic force between the positive and negative charge and hydrophobic interaction, that is nothing but van der Waals forces. So these forces will stabilize the three-dimensional structure of tertiary protein structure. One is primary protein structure is a normal chain, secondary structure is exists in the alpha helix structure and beta pleated structure. Tertiary is further folded of the tertiary secondary structure. Quaternary protein is that may be exist in the any three-dimensional tertiary structure because each one subunits together, that is called quaternary structure. That's why it is generally protein denaturation means unfolding of a three-dimensional structure of tertiary protein only. Why we can't say that quaternary mean quaternary nothing but each subunits. That's why it is mainly unfolding, folded. There is unfolding of a three-dimensional tertiary protein structure is called denaturation. When it is unfolded, their intermolecular forces that may be hydrogen bonding, disulfide linkage, hydrophobic interaction, all will be breakdown. When it is breakdown, their natural biological activity is lost. Then it is called denaturation or denatured protein. Natured protein means that is active protein which is found in the biological system having biological activity. Denatured means what is that? When you are doing some physical change in the protein structure, then its activity loss, that is called denature. De mean to remove. Natural activity is removed, that is called denatured protein. In that, we will discuss what are the physical changes if you do in the protein, then it lost its activity or unfolding. For example, change in pH. If you do change in pH, if you change pH, so what are the possibilities are there? At normal condition, consider that is neutral condition, a protein is exist and it exhibiting its biological activity. So we can change. One is pH is less than what it having pH, that is acidic medium, consider acidic. Another is pH greater than, so that is called basic. In acidic medium, what will happen? Generally, zwitterion, already we know that zwitterion can exist in the a dipolar neutral species, that is. So in zwitterion in acidic medium it having positive charge, zwitterion in basic medium it having negative charge. A polypeptide chain, that is a protein only. It acidic medium it having positive charge, that positive charge are for example C terminal. Generally in protein last part is COH. So this H plus may loss in basic medium and this NH2 group, it may be protonated in acidic medium. So they may lose their protons or gain proton, or they may lose their charges. For example, exist maybe in the zwitterion form, COO minus form and NH2 form, NH3 plus form is there. So in acidic medium it should exist in the positive charge and in basic medium it should be exist in the negative charge. If you add, it means changing pH in decreasing pH means that is acidic medium. So this CO minus gain the proton because it is acidic medium and it lost its charge In basic medium, it H plus, basic medium in OH minus. OH minus and this H plus loss as a water molecule. Then here also positive charge loss. Due to loss in negative positive charge, their electrostatic force of interaction is breakdown. That's why its activity loss. This is change in pH. One of the example, if you consider milk, curdling of milk. Due to some bacteria, milk is converted into curd, because in curdling of milk, first that carbohydrate, milk is nothing but one of the lactose. So that carbohydrate is converted into lactic acid. Lactic acid means it is acidic medium. Due to this acidic medium, it is pH is decreased. In that acidic medium, those are the soluble proteins are there that will be precipitated down. That is only called denaturation of protein. So curdling of milk, that is denature protein in changing the pH. And this is a one physical change if you do in protein, then it going to denature. Second one, we know that urea. Another one is guanidine. It is one of the strong base, guanidine hydrochloride, HCl. So this guanidine hydrochloride urea, anyone maybe, not both combined, urea may be added or guanidine hydrochloride may be added to the any one of the protein. Then these will form hydrogen bond with the protein. Already we know that in protein having some hydrogen bond, compare with that hydrogen bond, these urea or guanidine hydrochloride forming hydrogen bond with the protein, that is stronger. Compare with the hydrogen bond exists within the group of the protein. So this hydrogen bond stronger than that bonds, and it changes its activity. That's why by adding urea or guanidine hydrochloride also, that protein will be denatured. And third one, changing the temperature. If you change the temperature, we know that already one of the egg, unboiled egg, in that soluble proteins are, that is globular protein, that is albumin. Albumin is a soluble protein. When you small change in its pH temperature, it means it is sensitive to heat, then that protein, albumin protein, will be on heat, it converted into a rubbery moss solid, and this is hydrogen bond or the disulfide linkage will be breakdown when you heat the any one of the protein. So generally one of the most affected in the protein native activities, temperature and generally pH. So if you heat the any one of the protein, compulsory their movement of molecule will be increases, and their bonding between that functional groups, that may be easily break down, that may be disulfide linkage or hydrogen bond or van der Waals forces or hydrophobic interaction, or that may be electrostatic force of interaction. Next one, fourth. The fourth one is, if you dissolve in any one of the solvent, dissolve in solvents. For example, a protein dissolved in the non-polar solvent. So already we discussed that protein having like this NH2 CH, general amino acid structure I am writing here, COOH. This is which one? Alkyl group. Alkyl group is which one? A hydrophobic part. In this non-polar solvent, if you dissolve that long chain, these are having the non-polar part, that is hydrophobic part. So these hydrophobic part will be interacted with this solvent. Otherwise, if you dissolve in the polar solvent, so these polar group may be bonded with the polar solvent with the hydrogen bond. Then due to this bond, automatically their activity will be changed. So this is also called denature protein. So now this may be question, it is denaturation of protein is reversible process or irreversible process. Generally many of the proteins is irreversible. Irreversible means we cannot regain this is. Already we know that a boiled egg on boiling it will be converted to a rubbery mass solid. Again on cooling we cannot get the unboiled egg. It is not possible. And another example, milk is converted to curd. So curd we cannot get into again milk. This is not possible. This is irreversible process. Only one direction. Milk converted to curd, only one direction, but curd will not convert to milk. Unboiled egg is converted to boiled egg, but boiled egg will not convert into unboiled egg. But some proteins, very rare cases, that proteins are converting to reversible. That is, proteins are dissolved into a salted solution, salted out solution. If you dissolve some protein in that salted out protein, that may be denatured. In that is only mild denatured. If completely denatured means it is not possible. If mild denature of the protein, that can be reversible. A protein dissolved in the salted out solution, it denatured, that is mild denatured. Again it is removed and dissolved into the a less concentrated salted out solution. In that it will be again it getting its natural activity, that is called native protein. So protein denaturation is reversible and irreversible also, but maximum cases are irreversible. Very rare cases are irreversible. But already I told you that the many proteins are denatured in the change in pH and temperature, but few enzymes nothing but which one? Proteins only. So that proteins are, they are active in very strong acidic medium also. We know that amylase and trypsin, these are the present in our body. These are useful in our digestive system also. That's why these are very active in very strong acidic medium. So not always all proteins are by changing the pH or very at acidic medium they lost their activity, but few will be there. They are very active at the very strong acidic medium also. So once again I am telling that what is the protein denaturation. First we should know that what is the native protein. Native protein means in three-dimensional structure, that is tertiary structure. They having the biological activity. If lost their biological activity or unfolded, the three-dimensional structure is called denaturation protein. In denaturation of protein, keep in mind secondary and tertiary structure will be affected, the primary structure will not affected. And why not I am discussing about the quaternary? Quaternary structure is a mixture of the subunits, that is together. That may be two-dimensional secondary protein structure or tertiary protein structure are together. That's why I am not discussing about the quaternary protein here. So denaturation of protein affected only secondary and tertiary protein structure, but not a primary protein structure. That is a normal chain structure will not affect it, because in there only covalent bond is there. There is no any interaction like hydrogen bond, electrostatic force of interaction, van der Waals forces, that is not existed. Covalent bond is a stronger bond compared with the what we discussed, the disulfide linkage, hydrogen bond, and electrostatic interaction and hydrophobic interaction. That's why a primary protein structure will not affected with this protein denaturation. Thank you very much.